Here we have SAT math problem. Okay, let's go to the question. If 4k negative x is a factor of x to the third power negative 72 n k cube, where n and k are constants and k is greater than 0, what is the value of n? Okay, here when I consider this stuff and this stuff, we have three alphabets, k, x and n, and there is an information that n and k are constants. Then the alphabet x has to be considered as a variable. Okay, now we can consider this expression as a polynomial function p of x. That is, let p of x equals to x to the third power negative 72 times n k cube. Okay, the question says this is a factor of this one, that is a polynomial function p of x. Now I can equate this factor to 0 and solve for the variable x. Okay, let me do it. That is 4k negative x equals to 0. Now let me add x to both sides of this equation. Then negative x positive x will cancel out. I am getting 4k equals to x. Okay, here I equated this factor to 0 and solve for x, that is x equals to 4k. Now we can consider the factor theorem. When this 4k negative x is a factor of the polynomial function p of x, then when I plug in the value of x, 4k for x over here, it must be equal to 0 according to the factor theorem. So that is a p of 4k equals to 0. Okay, now to get the stuff for p of 4k, we have to plug in this 4k for x over here. Then we have to plug in the same 4k for x over here on the right side. Then I'm getting 4k whole to the third power negative 72 times n times k to the third power equals to 0. Okay, here two values are multiplied and there is a common exponent 3. So we can take this exponent 3 separately for each value and multiply the results. Then I'm getting 4 to the third power times k to the third power negative 72 times n k cube equals to 0. Okay, the value of 4 cube is 64. That is 64 times k cube negative 72 n times k cube equals to 0. Okay, here we find k cube in common in both the terms, so we can factor k cube out. Okay, when k cube is factored out, we are left with the 64 in the first term and negative 72 n in the second term equals to 0. Okay, here the product of two quantities equals to 0 here. So whenever the product of two quantities equals to 0, one of them has to be 0. I am pretty sure this one will not be 0 because the question says k is greater than 0. When k is greater than 0, k is not equal to 0. When k is not equal to 0, then this k cube also will not be equal to 0. That is, k cube is not equal to 0. But I want this product to be equal to 0. And when the k cube is not equal to 0, then this one must be 0. That is 64 and negative 72 n must be equal to 0. Now let's solve for n in this equation. Let me add 72n to both sides of this equation. Then this negative 72n, positive 72n will cancel out. I am getting 64 on the left side. On the right side, I am getting 72n. Okay, now let me divide both sides of this equation by 72. When I do so, this 72 will cancel out. On the left side, here we can simplify this one. The greatest common divisor for the numerator and denominator is 8. That is 8 goes into 64 8 times. And 8 goes into 72 or 9 times. I am getting 8 over 9 on the left side. On the right side, we have n. Therefore, the value of n is 8 over 9.